Okay, cool. So the reason we did all this was because I wanted to write my unit tests using actual deploy scripts because I prefer to do that. But like I said, it might be a good idea for you to write unit tests before you write your deploy scripts and then integration tests with your deploy scripts. But in any case, let's go ahead and finally create a test in here. DSC engine test.t.sol. And remember, the whole reason we're doing all this, I know we've been coding a lot, is in the DSC engine. We added a ton of functions in here. Some of them like get USD value, which we definitely want to check. Get collateral account value. We want to make sure minting works, our constructor works, depositing works, etc. So we're just kind of testing as we go along. Which, like I said, when I'm actually coding this, I did write tests and I did write deploy scripts because I did want to test as I was going, right? I didn't want to have to go back and refactor and rewrite my code if I made some glaring mistake, right? It's really good to test while you're building as well. And to be honest, I feel like it makes me go faster because I have more confidence that what I did was correct while I'm coding. So SPDX, license, identifier, MIT, pragma, solidity, 0.8.18, little caret here. Contract, DSC engine test is test. Import test from forge std/test. That's all, like this. All right, cool. Function setup, public or external. We're gonna need to deploy our contract. So we're gonna import deploy DSC from //script/deploy dsc.s.sol. Deploy DSC deployer. We're going to say deployer equals new deploy DSC like that. Again, I'm using a lot of tabs here. And we're going to say we're going to need the import decentralized stablecoin from //src/decentralized stablecoin.sol. We're also going to need to import the engine, the SCE from. Again, this is where GitHub Copilot can really make your life a lot easier. Just being able to hit tab here or just whatever AI that you're working with. Now we're going to say DSC. Let's actually make these. We'll say decentralized stablecoin, DSC, and DSC engine. We'll call DSCE. If that's confusing, you call this like engine or something. I'm going to call mine DSCE. So now our deploy returns DSC and the engine. So I'm going to say return DSC, DSCE equals deployer.run. Okay, that looks pretty good. There's a bunch of stuff more for us to do, but at least we have our tests set up here. So one of the first tests that we want to do is this price feed test, right? We want to make sure this get USD value, this math that we're doing here, because we're doing some weird math stuff, we want to make sure this is actually working correctly. So I'm going to set up a little price feeds tests section, price tests, like this. We're going to say function do test get USD value. And here we're going to test our get USD value function. So it gets passed a token address and an amount. So we're going to need to get those tokens that we use to deploy this. We can get that pretty easily from our helper config. So what we can do actually back in our deploy, we can also have this return the config. And just at the bottom, we'll also have a return config, comma config, and config will be the helper config, config, import that, import helper config from .script, helper config.s.sol. Okay, cool. And now we can get the WETH address, and we can also get the ETHUSD. So we'll put those up at the top too. We'll say address ETHUSD price feed, and we'll say address WETH. We'll get those from the helper config. So those are the first two. So it's ETHUSD price feed. Bitcoin price feed goes here. So comma WETH, comma, this is the Bitcoin token, comma, this is the deployer key, equals config dot active network config. Cool. We have the price feed and we have WETH. So now we can finally go down here. You set this function up. So we'll say uint256 ETH amount equals, let's say there's 15 ETH, right? 15 ETH. If we have 15 ETH, times it by $2,000 per ETH equals what? 30,000, 30,000 E18, right? Real simple math. So let's do that. uint256 expected USD equals 30,123, $30,000. And we'll say uint256 actual USD equals dsce.get USD value, WETH, and ETH amount. And the reason this should work is because in our engine, we pass the token and the amount, and internally it uses the price feed associated with that token, calls the price to get the amount. And now we should be able to just do assert equals expected USD and actual USD. All right. I know there's a lot of setup just to write this one test, but like I said, I like making sure my deploy scripts are part of my test suite right from the beginning, but it might be a good idea to just do them as integration tests. So forge test -m test get USD value, and it works. Now, I will point out, the first couple of times that I ran this test, I actually failed miserably. I got a number of things wrong, and that's okay, because you will, and that's why you write tests. So I also, while I'm here, let's also write at least one deposit collateral test. So let me copy this, paste it here, because we're going to write a lot of deposit collateral. Deposit collateral tests. Make it look a little bit pretty, at least. Like that. We can do some more simple tests like function test revert. Reverts if collateral 0. Public. We'll prank a user. So up at the top, we'll do an address public user equals make ADR user like this. Make user capital. User, let's say vm.start prank our user. Now we'll at least approve the token can go to the protocol. So we'll do ERC20 mock WETH. Do we have that imported? Nope. We're gonna have to import that. Import ERC20 mock from @openzeppelin /contracts/ what is it? Mocks / or contracts mocks ERC20 mock. Okay. ERC20 mock.sol. ERC20 mock WETH dot approve. Address DSCE, some amount. Let's do at the top. Let's make another uint256 public constant amount collateral equals, let's say 10 ether worth of collateral. Down here, we'll approve that 10 collateral, and then we'll do vm.expect revert with DSC engine dot. We're going to need to use that needs more than 0 in here. Needs more than 0 dot selector. And now you guys know what the selector bit means. DSCE dot deposit collateral. Say WETH 0. This, and then vm.stop prank. And actually, this might fail for a different reason, but let's go ahead and try a forge test -m. Oops. Okay, cool. And this actually did pass. Now, if we want to make this a little bit better of a test, we should also mint our user some WETH. And we probably should do that right in the setup so we don't have to do that for every single test. So what I'm going to do is I'm going to do ERC20 mock WETH dot mint user. We're going to do a uint256 public constant starting ERC20 balance equals, and let's say this is 10 ether as well. 10 ether. Starting ERC20 balance. Boom. All right, cool. So now forge test. All of our tests are passing. Cool. And like I said, I'll do this kind of as a sanity check to make sure that my architecture is even making sense, right? So what we probably also want to do next then is have a test for collateral is being deposited in these data structures. But for now, I'm content with these tests. So I'm just going to go back to writing my contracts. Like I said, there's no one single process, and I don't think I've ever written a smart contract completely in one go. I'm pretty much always writing tests as I'm writing the code. So it is a really good idea to do this. Yes, you do not have to write the deploy script as you're writing your code, but it's something that I like to do. And then, you know what, while we're writing these tests, let's also do -- fork URL, Sepolia, RPC URL. Let's also do this, because this probably will fail actually, because we can't just mint WETH out of thin air, and we do indeed fail. Test get USD value. Oh, interesting. That's the one that fails. Test get USD value. This one fails because we're hard coding the expected USD right here. And of course, the price on Sepolia is the actual price, as opposed to kind of this fake price that we're making up. So we should probably update this test to make it more agnostic, right? We probably should update this test so that instead of just hard coding 3000 in here, update this test to use the price of the actual price feed. For now, I'm going to leave it as is, and then I can fix it later for running those fork tests.